So the next component which present in biosensor, components of biosensor, is basically a transducer. So I have now received the combination of chemical reaction which has happened between bioreceptor and analyte, specific analyte. So the interaction is happened, some chemical reaction happened, and I got some signal, physical signal. Now, next part comes that is most important. Now the transducer. So basically, this transducer is a basic part device of a, or component of a biosensor, which converts whatever biological signal produced by bioreceptor, and we can say that the interaction between analyte and bioreceptor produces some signal, and that signal now needs to be converted into some measurable signal, and this transducer does that basically. So it acts as an interface between bioreceptor and the next part, that is maybe any electronics part which is we are using for further processing. So it basically serves as interface between basically interface which measures the physical changes occurring because of at bioreceptor end, and converts those energy what are created into a measurable electrical signal, so that we will be able to process that electrical signal in a better way, and we can have processing of that electrical signal. So this signal can be in the form of electrical, thermal, mechanical, it may be optical, or depending on what kind of sensor we are designing, what application we are processing, a lot of things will get involved as we go into deeper what kind of form of that particular signal will be. So now this transducer plays an important role. So what kind of transconduction mechanism which we are using in this transducer? So it may be pH change happening, it may be heat generated, it may be light proton, it may be mass change happening, it may be an electroactive substance present, it may be a pH change. So depending on what kind of transconduction mechanism happening, the transducers we are having different way to use it. So if I am having a pH change of my solution, I may go with a semiconductor based pH electrodes. If there is an electroactive substance, I may go with a basic electrode. If there is a change in mass happening before the reaction and after the reaction between the components, I may use an piezoelectric device which works on the piezoelectric effect. If there is heat generated, then I may use a thermistor. If there is I may use a photon counter detection for light. So depending on what kind of transconduction mechanism is my system is using, I can choose transducer's typical component or the type of transducer I may change. So it depends upon a particular application, what kind of transconduction mechanism is I want to use. And this transconduction mechanism is basically what output I am getting before transducer. That's what kind of mechanism I have to use. If there is a heat getting at the output of a bioreceptor, I may go for a typical type of sensor here in a transducer. So this is the same slide which we have already discussed. Here it is presented in a different way. What kind of transconduction mechanism, what are its types, and what happens in basically in those spatial categories. So the transducer is present. I have an optical transducer. So what dependent mechanisms, it may be an absorption phenomenon used, fluorescence may be used, interference of light is used. So what happens here? We basically measure the changes which is happening in a light intensities. So whatever light intensity changes, we measure those changes and appropriate signal is given to the next processing. So we may have electrochemical signal. So we have potentiometric, amperometric, conductometric, depending on whether voltage current is developed at the electrodes. So the whatever electric distribution is used as a measurement tool here. Now we have mass based, that is piezoelectric detection based system, a transducer. Basically, we have some in next. Here we use cantilever beam, micro cantilever beam. There we use a piezoelectric changes. So whatever mass change happen because of the pressure, we use this kind of technology. So change in the mass of analyte, we measure those changes and we'll use this such type of a transducer in some mechanisms. We have a temperature based like calorimetric detection devices. So whatever temperature changes, we are correlating with the signal. And last, which or one of the next is electrical and magnetic properties we may use. So there may be dielectric permeability properties we have to check. So in short, we will look for electrical and magnetic properties of a typical analyte and we will process those typical values. So these are the transducer types which we have already just discussed. Electrochemical transducers, which basically measure the electrical changes in the electrical properties. Those electrical properties may be current, voltage, impedance. So used in biomedical application, glucose monitoring. We have optical transducers, so which measures changes in light. We have already seen reflectance, absorptions, fluorescence. So used in optical transducers. We have a piezoelectric transducers. So basically this special category measures the changes in mass or pressure by detecting vibrations or resonance frequency changes. So this is basically used in mostly in sensors detecting DNA or other new molecular binding events. So we have next is thermal transducers. So whatever heat generated to measure changes in heat because of biochemical reactions, typically used in calorimetric biosensors. And then we have magnetic transducers. We use the magnetic properties, often basically used in applications like immunosensors, where we have magnetic bed structure. So those are the different transducer type in short, which we have already seen now.